Hey everyone, Professor Baldwin here, and today we have a word problem about a wind-powered generator. We're told that this wind-powered generator has blades that create a circular path with a diameter of 10 feet, and that creates a wattage, W, generated by a wind velocity of V miles per hour, and it's modeled by this function. So W, the wattage, is equal to 3.8 times V cubed. The first question asks if the wind velocity doubles, what happens to the wattage generated? Well, what does it mean for the velocity to double? That means velocity, which is the variable V, is being multiplied by 2. So if our V becomes 2V, and then it gets cubed, what's happening? Well, the 2 gets cubed and the V gets cubed. And 2 cubed is 8. So this velocity went from V to 8V cubed, which means it increased by a factor of 8. Now, part B wants us to solve the function for V. Now, remember, the V in parentheses on the left is just part of function notation. So we could rewrite this as W equals 3.8 V cubed. And to solve for V, first we need to divide both sides by 3.8. That brings us to V cubed equals W over 3.8. And we need to solve for just V, not V cubed. And when you have a variable being cubed, the opposite operation is to take the cube root. So we're going to take the cube root of both sides, which will leave us with V. And then on the right, it's the cube root of W over 3.8. And that's as simplified as we need to get. Part C says if the wind generator is producing 30,400 watts, find the wind speed. Well, 30,400 watts is our variable W, and the wind speed is V. If we want to find V, we want to use this new equation, the one that we just rewrote in terms of V. So V will equal the cube root of 30,400 divided 3.8. If we do the division inside the radical first, we're finding the cube root of 8,000. And that is 20 miles per hour.